Namaste. Today we will do remaining questions from exercise 6.5. Fifth question. ABC is an isosceles triangle with AC equal to BC. If AB square is equal to 2AC square, prove that ABC is a right triangle. We have to show that this is right angle. That means ABC is a right triangle. So in this it is given AC equal to BC and here AB square is equal to 2AC square. These are given in the question. Now let us split this. That is AB square is equal to 2AC square. We can write like AC square plus AC square. Now instead of 1 AC we will substitute this BC. So this become AB square is equal to AC square plus BC square. Now look at the figure. AB square is equal to AC square plus BC square and it is the converse of Pythagoras theorem. That is hypotenuse square is equal to base square plus altitude square. So converse we can say therefore angle C is equal to 90 degree. That is triangle ABC is right triangle. Next question. ABC is an equilateral triangle of side 2A. Equilateral triangle means all the sides will be equal. So here 2A, 2A and 2A. Now we have to find the altitude. Altitude is the perpendicular line drawn from the vertex to the other side. Here it will be 90 degree. We have to find this value, that is AD. Now let us consider these two triangles, that is triangle ABD and triangle ACD. In that we have AB equal to AC. Both are 2A. It is given in the question. Now AD and AD are common. AD equal to AD common. Also here 90 degree, here also 90 degree. So angle ADB, that is this angle, is equal to angle ADC, that is this one. Angle ADC, 90 degree. So according to RHS congruency, we can say this triangle and this triangle are congruent. That is triangle ABD congruent to triangle ACD. In RHS congruency, we have one right angle, hypotenuse and one side. Here we have right angle, hypotenuse is here, 2A and 2A, this one. So hypotenuse and one side is here, AD equal to AD. So RHS satisfies. So these triangles are congruent according to RHS congruency. Now if these two triangles are congruent, we can say these sides are equal according to CPCT. So BD equal to DC. Reason is CPCT. Now if this is 2A and if these two sides are equal, we can say this is A, this is A. So we got 2A and A here. Now let us consider one of the right triangle here. We can see two right triangles. We will consider one right triangle. Let that be triangle ABD. In that we have AB is hypotenuse. So hypotenuse square is equal to AD square plus BD square. According to Pythagoras theorem, hypotenuse is equal to altitude square plus base square and we know AB square is 2A whole square. AB value is 2A, square means 2A whole square equal to AD square we don't know plus BD square. BD means this length and we got it A. So A square. Now we will keep AD square on one side. We have 2A whole square on other side. 2A whole square means 4A square. 4A square, that is squaring 2 and squaring A. So 4A square is there on the other side of equal. Now along with AD square we have A square. We are taking that A square to the side. It becomes minus A square. So AD square is equal to 4A square minus 1A square, that is 3A square. Now we have to find AD, not AD square. So taking square root on both sides, AD square becomes AD. Here 3 taking square root, it becomes square root 3. A square's square root is A. So the value of AD is, that is altitude is root 3A. Next question. Prove that sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. So here we have to prove side squares sum, that is AB square one side plus BC square plus DC square plus AD square is equal to sum of the squares of diagonals. Diagonals are here AC. So AC square plus BD square. This is what we have to prove. For that, first we will check the rhombus, and we know rhombus diagonals bisect each other. So bisection means this length and this length will be equal. That is DO is equal to BO and AO is equal to CO. It is the property of the diagonals of a rhombus. Now keep it there. Now coming to one triangle, that is triangle AOD. In that also one more condition is there. Here it will be right angles. It is the property of the rhombus. So in AOD, that is this triangle, we can see it is a right triangle. So we will write AD square is equal to, that is, this is the hypotenuse, is equal to DO square, that is altitude square plus base square. I am talking about this triangle. So DO square plus AO square. According to Pythagoras theorem, hypotenuse square is equal to base square plus altitude square. Now similarly we can find other three triangles and their hypotenuse, that is this will be DC square is equal to DO square plus CO square. Now here BC square is equal to, that is this BC, again BO square plus CO square. One more triangle is the AB square. AB square is equal to AO square is the base and BO is the altitude, BO square. So we got four equations, 1, 2, 3, 4. Now we are going to add the equations. So on the LHS part we have AD square plus DC square plus BC square plus AB square. And on RHS part we can see, adding all these equations, we have 2 DO squares, now 2 AO squares, 2 BO squares and 2 CO square. So we will write it as AD square plus DC square plus BC square plus AB square. Adding these four equations, we got this LHS is equal to 2 DO square plus 2 AO square plus 2 CO square plus 2 BO square. Now taking 2 outside as common, we can write this RHS part as 2 into, inside the bracket we have DO square plus AO square plus CO square plus BO square. Now inside the bracket we can see AO and CO, and we know they are equal length because diagonals bisect in a rhombus. So AO length and CO length are equal. So instead of this we will write AO. That is, instead of CO we will write again AO because these two lengths are equal. Also you can see this is DO, this is BO, and it is a diagonal and they bisect. So they are same length. Instead of DO, we will again write BO. So this becomes 2 into, here I am writing it as BO. Here instead of CO, I will write AO because these two lengths are equal, these two lengths are equal. Comparing with the figure. So AO plus AO is 2AO square plus here BO square plus BO square 2BO square. Again we have 2 common, so we will take that 2 outside. So 2 into this 2 taken outside, 2 2s are, so we can write it as 4, and inside the bracket we have AO square plus BO square. 4 into AO square plus BO square, I am opening this, that is, this become 4AO square plus 4BO square, and If you are taking square roots inside and taking the square outside, this we can rewrite as 2AO whole square. Check it with this. 2AO whole square is 4AO square. That is 2 square is 4 and AO square is AO square. So 4AO square can be written as 2AO whole square. Similarly, 4BO square can be written as 2BO whole square. Now check with the figure. 2AO. 2AO means AO plus AO, that is total length is AC, plus 2BO. BO length is this. Again 2BO means total length this. That is BD square. So on LHS part we have AB square plus BC square plus DC square plus AD square. That is what asked in the question. And on RHS part we got this result. That is what we have to prove. AC square plus BD square.